Assalamu alaikum. Welcome to my presentation on big data analysis using Amazon Find Food Review dataset. In this presentation, I will explain the dataset analysis steps, insights, and how big data helps us understand customer opinion more effectively. Let's go. First of all, I explain this dataset. The Amazon Find Food Reviews dataset contains thousands of customer reviews on food products from Amazon, including review text, ratings, and sentimental analysis and understanding customer opinions, making it is a useful dataset for NLP and data analysis tasks. In the dataset, I do work basically four tasks: clean text data, analyze sentiment, visualize insights, build ML models. Uh, I use in the dataset, basically I download the dataset in Kaggle, which raw 5 lakhs. Key columns, text, summary, score, and time, and ideal for NLP and sentiment analysis due to rich customer feedback. And tools and environment: Google Colab and Python, tokenization, stopward lemmatization, and then vendor sentiment analyzer, logistic regression, Napier, and Matplotlib, Quad Cloud. Data exploration. First, four tasks in which tasks. One is first of all data loading and schema. Uh, then secondly হচ্ছে sample columns, third text length and missing value. Data loading and schema. Data set successfully loaded, confirming nearly 500,000 of records, schema and data type verified. Sample columns. This is initial views of summary, text, and score columns provided insights into review, content, and rating. Thirdly, text length. Character length of each review computes, showing distribution and review extensiveness. Last, missing value. Minimal missing values identified, indicating a clean dataset for NLP tasks. Second, my task: word frequency analysis. Identifying the most frequent words gives preliminary insights into customer attitudes. The top frequent word. Now, words like good, great, and best dominate, suggesting a generally positive tone even before sentiment processing. I do this work in Colab and then word cloud. Which visualization highlight the most frequent word, confirming the dominance of positive terms. Then text cleaning and pre-processing. Raw text was transformed into normalized, noise-free format for NLP analysis. First one is low caching, and this means ensure consistency, trading like Z, capital Z double O D good and a small z double O D good, and as the same token, all text in lower casing. Then punctuation removal. Eliminates noise, allowing NLP models to focus on symmetric meaning. Third, tokenization. Splits text into individual words until advanced NLP operation using. And stop word removal removes common meaningless words like is, this, to, that, this, to improve model focus. And then lemmatization. This is reduce words to their base form, like running. This is the base form run. Consolidating variation. Then sentiment scoring and summary. After cleaning, centimeter score were generated and a word count column was added. In this visualization, this is the word count column. It qualifies reviews length, useful for understanding test characteristics and sentiment strength. In this graph, we see that this is a 15 to 14. First of all, we first suppose I choose uh, five line of the code, and this is their range. And then sentiment score using data. Emotional polarity of each review on a continuous scale, which provide a preliminary sentiment indicator. This is the graphical representation. Sentiment analysis using data and ML model. Sentiment analysis classifies emotional tone. We used Vector and True ML model. Better sentiment analysis. Optimized for social media review. There is a score 0.05. This is a positive, and less than 0.05. This is a negative, else neutral. Result: most review are positive, followed by neutral and negative. Then logistic regression. This is the another best way to analyze sentiment analysis. This accuracy 80 to 90 or 95. Best performance on text data, handle large sparse matrix well. And then last, nav bias is a multinomial NB. This accuracy 70 to 78, faster but less accurate. Are from well on good what frequency data. In this analysis, I apply three models in this data set, Amazon Find Food Review, and my decision is logistic regression is the best way to calculate sentiment analysis in the data set. This is the visualization slide. Visual analytic techniques reveal customer sentiment pattern. First of all, sentiment distribution. I draw a sentiment distribution. This is positive, negative sentiment, neutral. Okay, in this sentiment distribution, clean dominance of positive reviews indicates overall favorable customer experience, and then sentiment analysis versus what count. Okay, longer review often carry a strong sentiment and polarity, implying emotional investment. And the last, positive and negative words. Positive like great, love; negative word disappointed, bad. This is the graphical representation. And the last came slides and conclusion. Overwhelmingly positive sentiment. The analytical report view that most Amazon food review express high customer satisfaction, strong emotional keywords. The negative reviews use powerful terms like bad, terrible, disappointed, and the review length correct correlates and with sentiment. Longer reviews often contain more emotional contents, both positive and negative, and logistic regression reliable model achieved good accuracy with TF-IDF for sentimental classification. This project successfully demonstrates NLP and then sentiment analysis and machine learning on a large text dataset, providing valuable insights into customer behavior. Then next I show my work in the dataset in Amazon Find Food Review dataset. This is a collab. I use collab. First of all, I install record libraries for loading dataset. This is a Mount Drive and load dataset. Using my Google Drive for load dataset. This is the dataset visualization. And then data loading and exploration. This is our data loading and exploration code, info and describe. This output provides an essential overview of the dataset structure or statistical properties. This total row count confirms the dataset was imported correctly and contains a large value of Amazon review. And then show sample columns, text and score. This output display the first few entities of the summary, text and score column. Then text length column. This is the length column overall. And then next, I use this code is null for generating missing value in this data set. This section quantities the missing value across each column in the dataset. Identifying null entities at this stage is crucial for determining whether imputation, removal, or other cleaning strategies are necessary. Okay, then top frequent word. I use this code for generating top frequent word. This output identifies the most frequently occurring words in the raw text corpus, and this is the graphical representation. This bar chart highlights the most common lexical items appearing in the dataset, and high frequency words provide early thematic indicators and then help identify dominant customer sentiment or product picture. And then text to text cleaning and preprocessing. First of all, I install the required libraries for execute this task. First of all, lower caching. Have this code for identify lower caching. Okay, then punctuation removal. Punctuation marks do not contribute to symmetric meaning in sentiment analysis. Removing them reduce noise and simplify tokenization, enabling the NLP model to focus on the actual words rather than the symbol. There is a stop word removal. A stop word like is, the, and, this, that. Minimal semantic value. Removing them reduces text noise, removes model focus on meaningful content. Then tokenization. Tokenization split the text into individual words until word units. This is the prerequisite for advanced NLP operation such as lemmatization, part of speech tagging, and feature extraction. Then lemmatization, then creating final clean data set. This is creating word count column. Each word count column in this code. The word count feature quantifies the length of each review. This attribute is useful for understanding text characteristics and can also aid in modeling your modeling tasks that consider review length as an indicator of symmetric strength. Then there is symmetric score column using Vedar. Okay, this is a graphical representation in symmetric score. And then task 3 symmetric analysis. First of all, I install the record libraries, then create new data frame and add Vedar sentiment, positive, negative. In which analysis, the result is most of the sentiment level is positive. Okay, then text block polarity and subjectivity. Then ML ready column. Then I use logistic regression and neighbors for symmetric analysis. Okay, this is our output logistic regression. In this data set, this is a high accuracy 94%, precision recall, F1 score explain correct classification ability, and positive plus show highest performance. So then use neighbors. Same to neighbors faster but slightly lower accuracy. This accuracy 90% and often misclasses neutral reviews. Okay, this is a confusion matrix, logistic regression and neighbors. Diagonal boxes show correct prediction and non-diagonal boxes show misclassification. These are compare both model, logistic regression and neighbors. In this analyzing, the result is logistic regression is the best choice for Amazon review sentiment classification. Then there is a visualization word cloud. Then there is a sentiment distribution bar chart code, and there is the output. This sentiment bar chart shows a clean dominance of positive review. In this data set, I analyze, and this output is positive review is very higher. Then positive and negative frequent words. This is the graphical representation. This chart compare high frequency token across positive and negative reviews. The sentiment score word count scatter plot. Okay, this is our graphical representation. Scatter plot. Longer review often carry a stronger sentiment polarity for negative and positive. Then time-based in this code, this output is this column not found in dataset. And then histogram of what count. There is a histogram. This histogram shows that most reviews are short-lived, typically between 10 to 15 words, indicates that users generally provide brief feedback. And then I create this report for based on collab code. This is our report. This is the table of content. I try to make sure to complete all tasks. This is data description. This is to learn environment. First one data loading and exploration. Okay, then show sample columns, text length column, missing value count, word frequency analysis, and then plot. This output graphical representation and text to text planning and pre-processing. Storyboard tokenization, lemonization, creating funnel. Okay, then creating word count column. Then this is sentiment analysis. In sentiment analysis, we chose two techniques. One is the better sentiment analysis, and another machine learning model. Machine learning model two types: logistic regression and Schnee bias classification. Okay, this is output, and finally, this is the visualization and compare the two types. This is the sentiment square and cloud, time-based no time cloud, and histogram of what counts. And finally, is the conclusion. This project successfully demonstrates the use of NLP, PySpark, concept and sentiment analysis, and machine learning on large scale of text dataset by cleaning and analyzing nearly 500,000 reviews. We have extracted meaningful pattern of customer review. Overall, the combination of better sentiment scoring, TF, IDF, and logistic regression provide a powerful and accurate sentiment analysis pipeline. And this is my presentation. Thank you for watching my presentation.